Next, we're going to investigate the connection between confidence intervals and hypothesis tests. This is something we've already touched upon before starting hypothesis tests by often asking the question about plausible values based on a confidence interval, but we'll formalize it a bit more in this topic. So we are going to use StatKey first to generate a confidence interval. We're going to generate a bootstrap confidence interval using percentiles from the nutrition study data set, and we're going to select the columns Quetelet, which is the same as BMI index, and smoke, yes or no. So going into StatKey, we want a bootstrap confidence interval. Since we have a quantitative variable, Quetelet, and a categorical variable, smoke, it makes sense that what we would look at is a difference of two means, so that what we're going to find a confidence interval for is the mean Quetelet for smokers minus the mean Quetelet for non-smokers, or maybe the reverse of this. So I'm going to go to bootstrap confidence intervals for a difference in means. I need to upload this file, nutrition study. And choose as my quantitative variable Quetelet and as my categorical variable smoke. And we can see that we have our sample showing up here. It doesn't look like there's a huge difference, right? There's a lot more non-smokers than smokers in our sample, but the shapes of these distributions and the relative positions of them don't suggest a dramatic difference in Quetelet according to whether they smoke or not. And a few thousand samples to get us started. Since we're using the percentiles method, I will select two-tail, and this gives me a 95% confidence interval, which starts at negative 0.016 and goes up to 3.271. Maybe I'll generate a few thousand more samples and let this stabilize a bit. Okay, negative 0.023 to 3.271. And so far we are just asking the same sorts of question that we were asking when we were covering just confidence intervals. Does it seem plausible that on average there's no difference in BMI between smokers and non-smokers? Well, no difference would mean mu sub s equals mu sub n. And it looks like we actually have a confidence interval for, let's take a look at this. My x1 bar minus x2 bar is positive, and it looks like no is a higher value than yes, so this is actually a confidence interval for mu sub n minus mu sub s that we have here. So if there's no difference, then that means that this difference is equal to 0. 0 is in this confidence interval, and therefore we would have to answer yes, it is plausible that there's no difference. Because mu sub n minus mu sub s equals 0 is a plausible value. Now, if we wanted to change this into a hypothesis test, notice that the question, does it seem plausible that on average there is no difference in BMI between smokers and non-smokers? That's really a yes-no question. So that's asking us, the null hypothesis is that there's no difference, mu sub n equals mu sub s. The alternative hypothesis is that there is some difference. So mu sub n is not equal to mu sub s. Based on the fact that we said 0 is a plausible value, and therefore it is plausible that there's no difference, what we have said in the language of hypothesis testing is that we would in this case fail to reject. it is still plausible that the null hypothesis is true. So the idea behind the link between confidence intervals and hypothesis tests is that if we have a confidence level that is a perfect complement to our significance level, then we can answer questions about a hypothesis test based on the confidence interval. So a 95% confidence interval can be used to answer hypothesis test questions that are two-sided hypotheses at the 0.05 level. So you can probably catch on to the pattern at this point. 99% leaves 1% remaining, and therefore this could only be used to reject at the 0.01 level. And here's the idea behind using a confidence interval to answer a hypothesis test. If we consider two situations, and we'll just consider these all in terms of a mean, but it works for any parameter. It's just easier sometimes to mark these with a symbolic expression. Suppose that both of these are confidence intervals for a mean mu. And that in this first case, my null parameter mu naught is somewhere in the interval. And in this second case, suppose that my null parameter mu naught is outside the interval. If my null hypothesis is that mu is equal to mu naught, this first picture shows that mu naught is a plausible value, which means that the null hypothesis is plausible. So this would be fail to reject. That's what we saw above. 0 was the value in our case because we were looking at a difference of means. 0 is the value we were looking for. 0 was in the interval, and therefore the null hypothesis is plausible, and therefore we fail to reject. In this second case, mu naught represents our null hypothesis. It's outside of the interval of plausible values for mu. This is what it looks like when we reject. So we're going to go ahead and generate confidence intervals for the same Quetelet versus Smoke question for each of these different significance levels. If it's helpful, change that 0.1 to a 0.10 anytime you see it so that you naturally think of it as 10% and not 1%. If my alpha is 0.10, then my confidence interval is going to need to be a 90%. So we'll need a 90% confidence interval for this. If my alpha is 0.05, we need a 95% confidence interval. That's the one we already have. So we could fill that one in. That is from negative 0.023 to 3.271. And if alpha is 0.01, which is like 1%, that leaves 99% for our confidence level. So we'll need to find a 99% confidence interval also. Coming back to our graph, all I need to do is change this to 0.9 to get my 90% confidence interval. That's from 0.286 to 3.028. And then I'll come back to StatKey again, click on this and change it to 0.99. And that gets me a 99% confidence interval, which in this case goes from negative 0.49 to 3.729. Yes. Okay, so the picture that we want to look at involves the number 0, because that's what our value of mu sub s minus mu sub n, or mu sub n minus mu sub s, would equal if there's no difference between the two. In this first example, it looks like here's 0, and my confidence interval consists of entirely positive values. In this second example, here's 0, and my confidence interval starts from a negative value and goes up to a positive value. 0 is barely in there, but it is in the interval. And this third example looks kind of like the second, except that 0 is a little bit more solidly in the interval. All we care about is whether or not that null value is in the interval. So in this first case, we would say 0 is not a plausible value. At the alpha equals 0.1 level, we would reject the null hypothesis. In these second two, 0 is a plausible value. For both of these, we would fail to reject. So we can furthermore tell something about the p-value from this. The fact that we would reject at 0.10 but fail to reject at 0.05 tells us that the p-value has to be greater than 0.05 or else we would have rejected, but has to be less than 0.10 or else we would have failed to reject. So it must be between these two values. It must be between 0.05 and 0.10. Now, just a note about using confidence intervals to answer questions about hypothesis tests. First of all, it really only works for a two-sided alternative hypothesis. Second of all, it's not something that we should choose to do if the primary question is about just a hypothesis test. We should still be able to get p-values from StatKey using randomization distributions, and that is the default method, is to get an actual p-value anytime we're just asked a hypothesis test. But if the objective of a question is, here we already have a confidence interval and the instructions specifically say to use the confidence interval to answer the question, that's when we would bring this in.